Okay, last one for today, I think. I'm not quite sure what else I can cover today. We're still on chapter 5, but okay, so we're going to take a look at our periodic table of the elements, and I know she is going to ask on the test, like, name for me, what is a transition metal? What is a halogen? Name for me a noble gas, for instance. And to do that, we're going to need to know how this is organized. So we're going to look at from the left of our periodic table here. We have our alkaline metals. That's this column here. We have our alkaline earth metals. We have our transition metals, and they go all the way up to the stair step here. We have our halogens and our noble gases. So we know the charges on some of these are always going to be the same. We know our alkaline metals are always going to be a +1. Our alkaline earth metals are going to be a +2. Our transition metals, they're kind of like a variable charge, and we know aluminum is always a +3, cadmium is a 2+, zinc is a 2+, and silver is just 1+. We know our halogens are -1, and I'm not quite sure what this one is called, but it is a -2. So there's our periodic table. Now that we know how it's organized, we know the charges on them. And take a look up at our board here, where I'm just going to say that we have 3 kinds of compounds that we are learning about in our class. We have type 1, type 2, and type 3. Type 1 is where the metal always forms one kind of cation. So taking a look down at our periodic table, we have NaCl. So sodium is our metal because chlorine here is a halogen. So it's a gas, it's not a metal. So Na, sodium, we know that always has a +1 charge. So that is not fooling us anywhere. So sodium chloride is pretty much how we name it. That one is really straightforward. We have our type 2, and that is where the metal can have a variable charge. So we're going to look down again at our periodic table, and our transition metals here, with the exception of these ones here, we don't know the charge. They're variable. They kind of just take on a different charge, or I don't even know what happens. All I know is that they have a variable charge. Like, we know the charges of these ones, but that doesn't stop it from being a type 2 compound. So we have our mercury oxide. We know that oxygen is a -2 charge. So to make it with no subscript, like right here, HGO, we're going to know that our mercury has a 2+ charge to be our cation. The ones that we said in class that are going to be the common ones, and I mean, from what I've noticed, that iron here is a common one. Lead can form different ones. Gold and chromium can all form different types of charges. And this one here, I mean, the type 2, you need to do a little bit of math sometimes to figure it out. But it's not that bad. Just always remember it's written with the Roman numerals there, so we know what the charge on the cation is going to be, right? It's not how many we have, it is what the charge is. So we have our type 3 is our last one. None of these here are metals. We have boron fluoride, we have nitrous oxide, and let me take a look in my textbook here. I was gonna have this open here. Basically, this is the one where we use our prefixes. So in the textbook here, we have our prefixes. We have mono, di, tri, tetra, penta, hexa, hepta, octa. This is on page 124. So we name our compounds using these prefixes here. So let's take a look. I've written them down. This is from the textbook that I wrote on the board here. Rule 1, we name the first element using the full element name, so it's boron. And the second element as it's an anion, fluoride. But this is where the tricky part comes in because we have 3 fluorides and only 1 boron. So we just say boron trifluoride. So tri is our prefix, mono di tri, so boron trifluoride. So the next one we have nitrogen monoxide. That's the kind of tricky one because we have 1 nitrogen and 1 oxygen. We don't say mononitrogen monoxide because that would be kind of weird. So we just say monoxide, nitrogen monoxide. And the third one, nitrogen oxide. Because there are 2 nitrogens and 5 oxygens, we're going to say it's dinitrogen pentaoxide. So if there is only 1, like in this nitrogen here, we just don't say it in the first one. If there is 2, we're going to say it's di. I think that's pretty much it. I mean, they're tricky. I mean, you have to take a quick look and realize where on the periodic table these guys are, the elements in your compounds. You have to figure out where they are on your table. Then you have to figure out what the charge is. If we don't know, it's going to be a type 2, and if there's no metal at all, like these are all gases, then it's going to be a type 3.